Hi, I'm Gabe Garza. I'm the CEO and founder of Reckon Point. Reckon Point develops robotic technology for indoor scanning, and recently we are starting to build new robots for disinfecting COVID viruses. Our main client base here at Reckon Point is architects for indoor scanning and 3D models using our robotic systems. Our newer clients in the disinfecting space are going to be hospitals, warehouses, and high traffic areas using UV light for COVID. We can speed up the process of scanning buildings with very, very accurate measurements using LiDARs, whereas our competitors use standalone laser rangefinders going from room to room. And so our technology helps speed up the process to develop these as-built drawings and 3D models for architects. The skills that we really have here is geared towards Python. We program a lot of Python. Additionally to that, we have a lot of electrical engineering skills here for all the wiring and PCB design. Another big skill that we use here at Reckon Point is mechanical engineering. When you're working on robots, there's a lot of dynamic forces that you got to account for as far as forward motions, sideways motions, stresses, gear ratios, torques. So definitely having a background in mathematics is very, very useful. So our robot is actually using quite a bit of Phidgets sensors and hardware. To start off with, we are using some Phidgets DC motors. They all plug into a Phidgets motor controller, a high voltage motor controller. That controller allows us to analyze and monitor the motor in real time. Some of the things that we get from that is RPMs. It's got a built-in PID, so it lets us control the set targets very accurately. We can monitor current, RPMs, temperature, and the encoders. So we take all that data and we can actively control exactly where the robot, how it's positioned and its attitude. In addition to that, we also use for proximity ranging sensing. We have we have actually 4 ultrasound sensors. Those are provided by Phidgets as well, and that allows us to measure distances in all 4 directions for obstacle and collision avoidance while the robot is moving. So we chose Phidgets for several reasons. When we started this new design on this ultraviolet light robot, we were looking for motor controls that provided better feedback. In doing that research, we found the Phidgets motor controls, and we tested them out, and they were very accurate. In addition, we saw that they had an API and a library for many other sensors, and so we said we'd give it a try. And we found that their API supported very well, and it was extremely easy to integrate. So it actually sped up our development probably by several months, as opposed to using independent sensors from various vendors and trying to basically write a protocol driver for every single sensor independently. This way, with the API, we can integrate all these sensors in a matter of days, not months. And it's very, very useful and very, very, very good product. So Reckon Point plans to start delivering these UV robots worldwide here in the near future. Next 6 months, we're going to go into low rate production, and then after that, we're going to look to go into high rate production. So those are the immediate plans for Reckon Point right now, is delivering these UV robots, where we see a lot of the new technology is going to be using more Phidgets devices to better equip these robots and to get to market faster. So what we have here, this is one of the main processors we're using right now. We're using a Raspberry Pi to emulate what our main processor is going to be. So this is actually running all the ROS, running master ROS. Next to it, the main interface, as you see here, USB, we are actually going into a Phidgets hub. The Phidgets hub is, I believe it's an 886, and everything is USB. We have one wire coming out of there doing DIO here. You can see here, let's see. And that allows us to remotely turn on and off another GPU board, processor board. So the Phidgets actually acts as using GPIO as a switch to remotely control another processor. These here, the motor controllers here, as you see, they are each running DC 1000 motor down here. Our DC 1000 motors here are using the encoders that gives us feedback to the motor controllers. And as we come down here, you can see the way we're using some of the jaw couplers to couple the shafts into the 30-to-1 gear drives. And those are all driving these mechanism wheels that are fully integrated into the system here. In addition, we use a couple of the range finders. You can see here one of the range finders up front, and then we also have some of the vent hubs here that we're using as well. So we got like two vent hubs. I believe we have one for the motor controllers and one for the range finders. And that kind of shows some of the hardware and how we're using the hardware within this robot for the Phidgets components, which actually makes up a lot of the hardware, believe it or not.